Hi everyone, welcome to my channel. This is Quantum Unicorn. The LeetCode problem we are solving in this video is intersection of two arrays 2. Well, the intuition behind this solution is to use a hash map, aka dictionary, to efficiently track the counts of elements in nums1. And by maintaining a count of each element in nums1, we can accurately determine the intersection with multiplicities when iterating over nums2. Let's break it down. First, we create an empty hash map to store the counts of elements. Then the code iterates over each element num in nums1. And if num already exists in the hash map, increment its count by 1 using this syntax. And if num does not exist in the hash map, then add it to the hash map with an initial count of 1. After finishing the first loop, it iterates over each element num in nums2, then check if num exists in the hash map and its count is non-zero. If the above conditions are satisfied, it means num is a common element between nums1 and nums2. Then append num to the result list and decrement its count in the hash map by 1. Finally, we turn the result list, which contains the elements that appear in both nums1 and nums2 with the correct multiplicities. So, in summary, the intuition behind using a hash map in the solution is that it allows efficient lookups and updates, which are crucial for determining the intersection with multiplicities. By storing the counts of elements in nums1, we can accurately determine if an element in nums2 is a common element and ensure that its count is correctly accounted for. The approach of the solution can be broken down into 4 steps. Step 1, count the occurrences of each element in nums1 using a hash map. And step 2, traverse nums2 and check if each element exists in hash map and has a non-zero count. Step 3, if a common element is found, add it to the result list and decrement its count in hash map. Step 4, return the result list containing the intersection of the two arrays. This approach efficiently handles cases with duplicate elements and ensures that the intersection includes elements with the correct multiplicities. By leveraging a hash map to track the counts, we can accurately determine the common elements between the two arrays and their respective multiplicities. With that said, now I'm going to give you a breakdown of the code and key learnings, which will help you better understand the approach. Well, key learnings 1, understanding dictionaries, which is hash maps. The hash map is the dictionary that stores the counts of elements from nums1. A dictionary is a data structure that maps keys to values. In this case, the keys are the elements from nums1, and the values are the counts of each element. The hashMap.get key default method is used to retrieve the value associated with a given key. If the key is not present in the dictionary, it returns the default value, in this case, 0, right? And 2, counting elements in nums1, the first loop iterates over each element num in nums1, and this line of code updates the count of num in the hashmap dictionary. If num is already a key in hashmap, hashmap num retrieves the current count and increments it by 1. And if num is not present in hashmap, hashmap.get num0 returns 0 as the default count, and then 1 is added to it. 3. And finding intersection in nums2. The second loop iterates over each element num in nums2. The 9, if num in hashmap and hashmap num not equal to 0, checks if num exists as a key in hashmap and its count is non-zero. If num is present in hashmap and its count is non-zero, it means num is a common element between nums1 and nums2. And if the condition is satisfied, num is appended to the result list, indicating its presence in the intersection. Additionally, the count of num in hashmap is decremented by 1 to account for its occurrence in the intersection, right? And 4, returning the intersection, the result list contains the elements that appear in both nums1 and nums2 with the correct multiplicities. After iterating over all elements in nums2, the result list is returned at the final intersection. So we can say the algorithm behind the solution is that first, create a hash map to store the counts of elements in nums1, and then traverse nums1 and update the counts in the hash map. Then traverse nums2 and check if each element exists in a hash map with a non-zero count. If a common element is found, append it to the result list and decrement its count in hashmap. Finally, return the result list, which represents the intersection of the two arrays. The time complexity of the solution is O of n plus m, where n and m are the length of nums1 and nums2 respectively. Why is that? Because the first loop, which iterates over nums1 to create the hash map, has a time complexity of O of n, where n is the length of nums1. The second loop, which iterates over nums2 and performs lookups in the hash map, has a time complexity of O of m, where m is the length of nums2. Since we consider both loops sequentially, the overall time complexity is O of m plus m. Okay? And regarding space complexity, it has a space complexity of O of minimum of n or m, where n and m are the length of nums1 and nums2 respectively, because the hashmap dictionary stores the counts of elements from nums1. The space required by the hashmap depends on the number of unique elements in nums1. In the worst case, if all elements are unique, the space complexity would be O of minimum n or m. And also, the result list stores the intersecting elements, and its space complexity depends on the number of common elements between nums1 and nums2. In the worst case, if all elements are common, the space complexity would be O of minimum of n or m. Therefore, the overall space complexity of solution is O of minimum of n or m. Okay? Alright, well, by understanding the use of dictionaries, which is hash maps, and the logic of counting elements and finding the intersection, you will gain a solid foundation for approaching similar problems and understanding more complex algorithms. Alright, that's all for today. I hope this was helpful. If you have any questions, please leave a comment, and also please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye.